Hey everyone, so we're going to continue here with some notes. So here's lesson, it's section 7.1 in the book, and we're going to deal with similar polygons, so similar shapes or similar figures. So if here we have, I guess, the definition of similar polygons. If two polygons are similar, and this is the symbol, the math symbol used to show similar. So if two polygons are similar, they have two properties. First, the corresponding angles are congruent. Okay, remember that, that's important. And second, the corresponding side lengths are proportional. Okay, and then in the previous notes we just went over what a proportion was. Think two equal fractions or two equal ratios. And kind of just in general, similar, we know two polygons are similar if they have the same shape. One's just bigger than the other one, okay, or one is smaller than the other. So real quick, if you look at these two down here, they have the same shape. One is just bigger than the other, so they're similar, okay. But if I move on, let me pause it here. This is telling me polygon ABCD is similar to polygon EFGH. Okay, and this in general is called a similarity statement. If you ever see write a similarity statement, that's just writing two polygons are equal to each or similar to each other. Okay, I put that here. I didn't want to have to rewrite that somewhere else. But anyway, if these two polygons are similar to each other, then I know the corresponding angles are congruent. Okay, that's the first thing. I put it in green. Corresponding angles are congruent, right? And I know which ones are corresponding because of the order that they're in. So I know A and E go together. They're not marked on here, but I know A and E go together, right? Same thing. Let's jump to the third letter, C and G. I know C and G match up, right? C and G, so those would be congruent. And then the second thing, the corresponding side lengths are proportional. So here's the corresponding side lengths. Take like AB, this side length, that one matches up with EF, so I write AB over EF. And then the next one would be BC, and then FG. Well, here's BC, FG. And then CD matches up with GH, CD, GH, and the last one is DA and HE, right? And you'll see in a second, these will be numbers, so you'll have like a proportion, okay? So that's two things. The corresponding angles are congruent, and the corresponding side lengths are proportional, okay? That's how we know, or that happens when two polygons are similar. And then the scale factor is, it's the ratio of lengths of two corresponding side lengths. So any one of these could be the scale factor, okay? It kind of tells us how big something is, or like what number we multiply to get it bigger or smaller. We'll have an example of that later. And then the last thing we have is dilation. I don't think we do much with this, but I did want to bring it up because in the first semester, I think in the first quarter, we did go over some transformations. But a dilation is just a transformation, and a transformation is when you change a figure or a polygon. A transformation that shrinks or enlarges a polygon. Okay, so it's going to make a shape bigger or smaller. And then the only thing we really need to know is a dilation keeps the two figures similar. They'll still have congruent angles, and the corresponding sides will be proportional. Okay, so pause that, finish copying it. I'm going to turn it over for the examples. So here we have some examples. So for the first two, I'm going to list all the pairs of congruent angles, and write the ratio of corresponding sides in a statement of proportionality. So basically write down what angles are congruent and the proportion of corresponding sides. Okay? So copy that, pause it, I'm going to move on. So if you look, you can either look at sometimes the figures have the angles marked. You could do that, or you can just look at the similarity statement. Here's the similarity statement. Again, I know angle P is congruent to angle D because they're in the same spot. It's the first letter here, and then I know angle Q is congruent to angle E, again because those are the second letters, and then angle R is going to be congruent to angle F. Angle R congruent to angle F. Okay, and then if I take the sides, I'm just going to take the sides in order. It goes P, Q, R, and then RP. Okay, so just like there's three angles, I should have three ratios here. Let's go with PQ. I know PQ matches up with DE. And then if I go QR, I know that's going to match up with EF. And then it goes RP, it goes back to the beginning. So it goes PQ, QR, and then RP. RP matches up with FD. So here's the congruent angles, and here's the statement of proportionality. And again, it's like this side matches up with this side, right? PQ and DE, and then you go this way. I'm gonna put 2 marks on it. Matches up with this side, and then the last one is this mark. So I'm putting these marks on them so you guys realize how they match up. So then these two sides match up. And then, well, that's it. So let's move on to number 2. Again, first we're going to write down which angles are congruent. Now this one has 4 angles. We can tell by the 4 letters. And over here, if you guys look, this is triangle PQR. We can write triangle PQR. They don't put, once it's bigger than a triangle, they don't put any of the figures up here. We can just call this polygon ABCD is similar to polygon HGFE. Okay, even though we know this is like a quadrilateral, probably we could call it a trapezoid. We don't name it like that, we just say polygon. So let's go with the 4 letters. A, B, C, D. And I just went in order, A, B, C, D. And then same thing, just go in order here, H, G, F, E. That's how they match up. H, G, F, E. Okay. And then be careful when you look at the figures, because this one is actually flipped upside down to this one. It doesn't match up nice and neat like this one, like these two sides go together. I know these two this top one and this top one does not go together because it's actually flipped upside down. Okay, so be careful. I like to look at the similarity statement and just take the letters in order. Like here's AB and HG. So here I would write AB and HG, and then go BC. Watch, I'm gonna write all these. CD. And the last one goes from D to A. So those are all the sides for this polygon. And then for this other polygon, again, I just go HG, I already wrote that one. Then go GF. And then go FE. And then EH. And again, I know all these angles are congruent to each other. These pairs of angles are congruent to each other. And then these corresponding sides are proportional. And here we can write a proportion. See, let's do AB, HG. Here's AB, which is 6. and then HG here is 9, right? If we take BC, I'm going to do the next one. BC is 4, and then GH is 6. I know these fractions are equal because these are proportions. This is a proportion, and remember, a proportion is 2 equal ratios. Okay, you could verify that real quick. So if you multiply this way, you get 36. If you multiply this way, you get 36. See, they're equal. That's one way you can tell fractions are equal, is when you cross multiply. But let's move on. So for this last one, there's a couple of things they want us to write. First, the similarity statement. They want us to solve for x and y and find the scale factor. Okay, so the similarity statement, because these are triangles, I can go ahead and write the triangle or use this triangle symbol. And then to name it, oh, I forgot to put letters on this one. Let me just go MLN, whatever. So to name it, I like to just follow the markings in order. L has 1 mark, and then M has 2 marks, and N has 3 marks. And then over here, same thing with this other one. Q has 1 mark, R has 2 marks, and then P has 3 marks. So that would be the similarity statement. That's how they match up. Okay. And then I know, again, this side matches up with this side. So I can write 18 over 12. So what I'm doing next is writing a proportion to solve for x and y. And then to solve for, let's solve for x. X matches up with 20 over here, right? And notice the 18 and the x both came from the triangle on the left, and the 12 and the 20 came from the triangle on the right. And then we just solve this. Okay, cross multiply here, 12x, cross multiply here, 18 times 20, that's 360, and then divide by 12, x equals 30. Okay, and then to find y, the same thing. I can use that same ratio that I started with, but the second one will be different. Y is the side on the left, so I'm going to take this number, 21 over y. And then again, solve this. Multiply this, that's 18 times y. Multiply these, 12 times 21. You get 252. Divide by 18, divide by 18. 14. Y equals 14. And the last thing we had to find was the scale factor. And the scale factor is easy to find. It's just, you can take and write a fraction out of the two proportions, 18 and 12. The only thing we do need to do is simplify that. 18, 12, that reduces down to 3 over 2. So I know this big one is 1.5 times bigger than this one. Okay, or this small one is 2/3 the size of that one. So let's move on to the next example. So the next example, unlike this one, see how this one's a triangle? This one's not a triangle, so I'm not going to put a symbol in front of it. But let's go to the letters. I'm going to go 1, 2, square 3. Okay, so it goes P, L, M, N is similar to 1, 2, square 3. K, G, H, J. Okay, those are the similar ones. And then to solve for x, first take proportions that we know, or side lengths that we know, like we know these two. So I'm going to write 6 over 4, and I always write it left on top, right on the bottom. We could go 4 over 6 if you wanted, but again, that's just my preference. I like writing 6. Whatever the figure is on the left side, I always put that one on top. So 6 over 4. And then if we want to solve for x, x matches up with this bottom number, left over right, and then we just solve this. Multiply 4 times x, multiply 48, divided by 4, x equals 12. Again, use side lengths you know, 6 over 4. And then to solve for y, where's y? Y matches up with this side length, left over right, and then multiply, cross products to solve. 6 times y, 60, divide both sides by 6, and then you get y equals 10. And then again, the scale factor. We could take this one as our scale factor. 6 over 4, but reduce it, divide both sides by 2, and you get 3/2. Okay, same as this one over here. And that's it.